This lesson is about measuring current in a series circuit. So our title today is Current in Series. By the end of this lesson we should be able to define current, describe how to measure current in a series circuit using a circuit diagram, and describe the link between current through a cell and current through other components in series. So we should write our notes in the Cornell note-taking system with our objectives on the left and our notes matching up to those objectives on the right. Then, at the end of the lesson, write a summary in your own words. So, current is the rate of flow of charge. That means it is the amount of charge which flows past a point in a circuit every second. So let's take a look at these examples to help us understand. In A, we have a large number of electrons flowing slowly. In B, we have a small number of electrons flowing slowly. And finally, in C, we have a small number of electrons flowing quickly. A and C are in fact the same current. This is because even though there are more electrons flowing in A, the electrons are moving faster in C. So if you were to observe the electrons travelling past you and count how many went past every second, you would find that the number that went past every second is the same in A as it is in C. Whereas B has a low current. This is because not only is there few electrons moving, but they are also moving slowly. So the number of electrons which pass through the wire every second is the same in A and C. They are the same current. So if we imagine a battery connected to two bulbs, we want to measure the current through a point in the circuit. If we wanted to measure the current through the battery, what we would do is we would add an ammeter. We could then look at the current through one of the bulbs, and we add the ammeter between these bulbs. Then finally, we want to measure the current at the last point in the circuit. What we will find is that since the electrons are travelling only through the wires and going nowhere else, that the current through the first ammeter, the second ammeter, and the third ammeter will be the same. In other words, the current is the same everywhere in a series circuit. That is because electrons are only flowing through these wires. They are flowing in one long circular loop. None of them escaping, no extra ones being added. So everywhere in the circuit, the current is the same. We represent current with the letter I. I means intensité de courant, coming from the French. So I represents current. We see that I1, the current through the first ammeter, is equal to I2, the current through the second ammeter, which is also equal to I3, the current through the third ammeter.